एस के बराबर होगा अगर एस के पास ऑलरेडी आइडेंटिटी होगी, क्योंकि उस केस में हमें कोई एक्स्ट्रा एलिमेंट नहीं जोड़ना है। अब अगर एस के पास आइडेंटिटी नहीं होगी, उस केस में हमें एक एक्स्ट्रा एलिमेंट इसके साथ जोड़ना है। तो उस केस में S1 क्या है? इट्स एस यूनियन वन। सो अदरवाइज इट इज एस यूनियन वन। अगर इसके पास आइडेंटिटी है इट्स एस, अगर इसके पास आइडेंटिटी नहीं है देन इट विल बी एस यूनियन वन। So now we define zero of a semigroup. As you know that zero of a ring, zero element of a ring with respect to multiplication, it's actually identity to identity in that case. If R is a ring, then with respect to it's a group, with respect to multiplication it's a semigroup, and it satisfies one more property that is called as distributive law. And the identity with respect to addition, it's denoted by zero element, and it's the zero element of the ring, because if you multiply this zero with any element of ring, it will be zero. So here with respect to multiplication we define the zero, because the operation is here multiplicatively. We define the element zero of a semigroup. As in case of the ring, we have a zero of a ring. Always zero is always there in rings, but here we need to define the zero element. And some rings has a zero element, and some rings does not possess such element. So let's define the zero of a ring. Zero of a ring. Semigroup with zero. Semigroup with zero. Semigroup with zero. Okay. If a semigroup S with at least two elements, if a semigroup S with at least two elements, with at least two elements contains an element that we denote by the notation zero. It's not the zero integer, it's a notation that we denote by this zero, such that 0 into x is equal to 0 is equal to x into 0 for all x in S. Suppose we have a semigroup with at least two elements, and this semigroup has an element 0 with this property, then this element is called a 0. Then this element is called 0. Then we say this 0 is a 0 of S. 0 of S. 0 element of S. And S is called a semigroup with 0. And S is called a semigroup with 0. S is called a semigroup with 0. तो सेमीग्रुप में जीरो का मतलब क्या है? इस सेमीग्रुप में एटलीस्ट दो एलिमेंट्स होने चाहिए, और अगर इसमें ऐसा कोई एलिमेंट होगा जिसको हम इससे डिनोट करेंगे जीरो नोटेशन से, जिसकी ये प्रॉपर्टी होगी 0 into x is same as 0 which is equal to x into 0, इसको किसी भी एलिमेंट के साथ हम मल्टीपल करो ये जीरो ही बन जाए, जो ये एलिमेंट जीरो आपने लिया है। तो अगर ऐसा एलिमेंट होगा इसके पास जिसकी ये प्रॉपर्टी होगी, ऐसे एलिमेंट को हम कहेंगे जीरो ऑफ अ सेमीग्रुप। ये सेमीग्रुप एस का जीरो एलिमेंट है। और अगर सेमीग्रुप एस के पास ऐसा एलिमेंट होगा देन सच अ सेमीग्रुप इज कॉल्ड एस सेमीग्रुप विद जीरो, एंड एस इज कॉल्ड एस सेमीग्रुप विद जीरो। सो नाउ if we have only, suppose it satisfies only this equation, suppose, then this element 0 is called the right 0. If it satisfies this equation then it's called left 0. So if S is a semigroup, if S is a semigroup, And if S is a semigroup, and there exists an element, say, let me denote that element by 0, 1 in S, such that 0, 1, or you can write it as here 0 R. Okay, R stands for right 0 R, such that 0 R into X is equal to 0 R for all X in S. For all X in S. Then this 0 R is called the right 0 of a semigroup S. Then 0 R is called the right 0 of S. And if there exists 0L in S, there exists 0L in S such that this one X into 0L is equal to 0L for all X in S. Then 0L is called the left 0. It's called the left 0 of S. तो एक तो हमने ये डिफाइन किया, अगर कोई एलिमेंट ऐसा होगा जो लेफ्ट 0 भी होगा राइट 0 भी होगा, उसको हम 0 कहेंगे, जो हमने ऑलरेडी डिफाइन किया है. अब अगर ऐसा एलिमेंट होगा जिसकी सिर्फ ये प्रॉपर्टी होगी, तो अगर हम इसको राइट साइड से मल्टीपल करें, ये इसको 0 बनाए हैं, 0 R इंटू एक्स इज इक्वल टू 0 R. ऐसे एलिमेंट को हम कहते हैं राइट 0 ऑफ अ सेमीग्रुप. और इसी तरह से अगर सेमीग्रुप में ऐसा कोई एलिमेंट होगा जिसकी ये प्रॉपर्टी होगी, अगर आप इसको किसी भी एलिमेंट से राइट साइड से मल्टीप्लाई करोगे तो ये इस एलिमेंट को किल करेगा. इट विल किल द एलिमेंट्स व्हिच आर ऑन द राइट हैंड साइड ऑफ इट. Then such an element is called the left 0 of a semigroup. Left 0 of a semigroup. So what now as an element 0 is said to be a 0 of a semigroup if it is both left 0 as well as right 0. So therefore we conclude that an element 0 is a 0 of S if and only if it is both right 0 and left 0. If it is both right as well as left 0. So again, as in case of the semigroup without identity, then in that case we can adjoin an extra element, and same is here. If the semigroup S is without 0, then we can adjoin an extra element to that semigroup S so that it will become the semigroup with 0, as in case of identity. Now if as a semigroup, if S is a semigroup without 0, then we adjoin an element, then we adjoin this element here, then we adjoin an extra element here, let me write here without 0 words, without 0, then we adjoin an extra element, then we adjoin an extra element 0 to S, and we define our operation. We define 0 into X is equal to X into 0 is equal to 0. and 0 into 0 is equal to 0 for all x in S. Okay, this semigroup is a semigroup without 0. तो हमने क्या किया, हमने एक एक्स्ट्रा एलिमेंट एडजॉइन इसके साथ किया जिसको हमने 0 से डिनोट किया है, इस नोटेशन से हमने इसको डिनोट किया। और इस एक्स्ट्रा एलिमेंट को ऐड करने के लिए हमें अब इस पर ऑपरेशन इसके साथ मल्टीप्लिकेशन डिफाइन करना है एस के एलिमेंट्स के साथ, ताकि जो रिजल्टेंट एलिमेंट है वो वापस इसी में आ जाए, एस यूनियन 0 में। तो वो हमने ऐसे डिफाइन किया 0 into x is equal to x into 0 is equal to 0। तो ये वापस इसी में आ जाता है s यूनियन 0 में, क्योंकि 0 को हमने इसके साथ एडजॉइन किया है। और 0 into 0 is equal to 0। तो हमने ऐसे यहाँ पर इसके साथ ये ऑपरेशन डिफाइन किया है so that it will become the zero element of the semigroup S. So then we can easily verify that this S union 0 is a semigroup with 0. Then S union 0 is a semigroup with 0, is a semigroup with 0, and we define as in case of the semigroup without identity, and we define as 0 is equal to S if S has already 0, and it's equal to S union 0 otherwise। तो सिर्फ हमने क्या किया, हमने हमारे पास सेमी ग्रुप था जिसके पास 0 एलिमेंट नहीं था, हमने इस 0 को एडजॉइन किया इसके साथ, तो हमारे पास एक नया सेट बन गया S यूनियन 0। अब हमें प्रूव करना है ये जो S यूनियन 0 है ये सेमी ग्रुप है और इसके पास 0 एलिमेंट है। वो 0 एलिमेंट कौन है, वही जो हमने इसके साथ एडजॉइन किया है। तो वही मैंने लिख दिया, S यूनियन 0 इज अ सेमी ग्रुप विद 0, दिस विद 0 0, जिसका 0 यही 0 है। And we define this S power 0 is equal to this. So as we have proved that identity is unique, now we prove that if S is a semigroup with 0, then 0 is always unique. So 0 of a semigroup is always unique. So if S is a semigroup with 0, a semigroup with 0, a semigroup S with 0, this 0 is a semigroup with 0, okay, a semigroup with 0, then 0 is unique, 0 is. The proof is very simple, as in case of the uniqueness of identity. So we again assume, suppose it has two zeros, say 0 and 0 dash. So assume 0 and 0 dash be its zeros. Then by definition of 0 into x is equal to x is equal to 0, which is equal to x into 0, and 0 dash into x is equal to 0 dash is equal to x into 0 dash for all x in x, for all x in S. So the 0 is the 0 of S, therefore it satisfies this equation, 0 into x is equal to 0 is equal to x into 0 for all x in S. Again, this 0 dash is also the 0 element of S, so therefore it also satisfies the same property, 0 dash into x is equal to 0 dash is equal to x into 0 dash. Now if we take the particular choice for this x, suppose here we put x equals 0 dash, then 0 into 0 dash is equal to 0 dash, which is equal to 0 dash into 0 dash by putting x equal to 0 dash, and here by putting x equal to 0, it is 0 dash into 0 is equal to 0, which is equal to 0 dash into 0. So again this is 0 dash into 0, which is equal to 0 dash. Here it is 0 dash into 0. This is again here it's 0. This one it's equal to 0, and here it's equal to 0 dash. Therefore 0 is equal to 0 dash. So that's 0 is unique. 0 is unique. Okay. But one thing which is very important here, that if we adjoin, suppose we have a semigroup S. Suppose this semigroup S is without 0. If we adjoin 0 to this semigroup may sacrifice some properties. It may lose some properties. Suppose this semigroup S is a semigroup. Suppose it's also a group. That's the extra property for this semigroup. It's a semigroup which is also a group. Suppose S is a group. Now suppose we adjoin the element 0 to this semigroup S, which is a group. Then this new set, which we will denote by T, it's not a semigroup with 0. It's not a group. Sorry, it's not a group. S is a group, but if we adjoin an extra element 0 to this S, which is initially a group, then the new semigroup, this one, it's which we will denote by T. This T is not a group. It loses this property. So by adjoining an extra element 0 to a semigroup without 0, it may lose some crucial properties, or it may sacrifice some crucial properties. Okay. So if we adjoin 0 to a semigroup S, it may sacrifice some properties. It may sacrifice some properties. Suppose S is a group. तो अगर हमारे पास सेमीग्रुप होगा जिसके पास आइडेंटिटी नहीं होगी, जिसके पास 0 नहीं होगा, सॉरी, जिसके पास जो विदाउट 0 होगा, तब अगर हम 0 को इसके साथ एडजॉइन करें, जो अब नया सेमीग्रुप बन जाएगा S यूनियन 0, जो कि सेमीग्रुप है विद 0, ये जो नया सेमीग्रुप आपके पास बन गया विद 0, इसमें वो सारी प्रॉपर्टीज नहीं हो सकती जो ऑलरेडी एस में होगी. तो वो मैं यहाँ पर एग्जांपल के साथ एक्सप्लेन करूंगा. सपोज ये जो सेमीग्रुप इनिशियली जो सेमीग्रुप आपके पास था, सपोज ये ग्रुप है था आपके पास, इट वाज अ ग्रुप सपोज. तो जब मैं इसके साथ 0 एडजॉइन करूंगा ना, तो नया सेमीग्रुप मेरे पास आ जाएगा विच इज एस यूनियन 0. वो जो सेमीग्रुप होगा वो ग्रुप नहीं होगा. एस के पास प्रॉपर्टी थी, एस ग्रुप था, मगर अब जो नया सेमीग्रुप बन गया वो बन गया विद 0. उसके पास वो प्रॉपर्टी तो आ गई 0 की, मगर उसके पास जो अच्छी प्रॉपर्टी था, which was a nice property group, the property it's a very nice structure group. It possesses inverse for each element, it has an identity. तो अब जो नया सेमीग्रुप आपके पास, इसके पास तो वो प्रॉपर्टी आ गई 0 वाली, ये तो बन गया सेमीग्रुप विद 0, मगर इसके पास जो अच्छी प्रॉपर्टी थी, ग्रुप की प्रॉपर्टी, क्योंकि खुद ये पहले ग्रुप था, वो प्रॉपर्टी इसमें अब नहीं रहेगी. So now let me prove that. Suppose S is a group, and let's adjoin 0. Let's adjoin 0 to S. Suppose S is a group. Obviously, you can say it has at least 2 elements, or say it's okay. So it's a group. So let's adjoin. Then S power 0 which is equal to S union 0 is not a group. ये group नहीं होगा. It cannot be a group. Why? Why it's not a group? Because in that, suppose it's a group. Suppose this is a group. Then if we take any element G, that 0, then this since if suppose it's a group, then every element of that group must possess an inverse, must have an inverse. Since 0 is the element of that group, so therefore 0 must has an inverse. So suppose on contrary, that S union 0 is a group. Suppose S union 0 is a group. And let G be inverse of 0, and let G belongs to S union 0 such that G is inverse of 0. That is, G into 0 is equal to 1, because 1 is the identity of group. 1 is the identity of group here, which is equal to 0 into G. But since this is the 0 of that semigroup, हमने एडजेंट किया है एलिमेंट. एडजेंट जब हमने एलिमेंट किया तो हमने डिफाइन कैसे किया, फिर ऑपरेशन को हमने किया था डिफाइन G x into 0 is equal to 0 for each x in S. तो यहाँ पर G, तो हमने G लिया इसमें, तो G S के एलिमेंट्स के साथ जब मैं 0 के साथ प्रोडक्ट करूंगा, इट विल बी 0, क्योंकि हमने एडजेंट किया इसको ऐसे ताकि ये 0 बन जाए. It's equal to 1. So that means this identity of a group is equal to 1, is equal to 0. So in that case, this gives x which is equal to 1 into x, which is equal to 0 into x, which is equal to 0 for all x in S union 0. S union 0. तो जो भी एलिमेंट इसमें है S union 0 वो किसके बराबर है, 0 के बराबर, which implies S union 0 is equal to 0, which is a contradiction. A contradiction. Or you can simply say here it's a contradiction. A contradiction. A contradiction. तो इस ये जो नया समीग्रुप बन गया S union 0, इसके पास ये वाली प्रॉपर्टी आ गई, 0 वाली प्रॉपर्टी, मगर इसके पास जो अच्छी प्रॉपर्टी थी, जो इसके पास ग्रुप की प्रॉपर्टी थी, वो अब इसमें नहीं रही. तो वही हमने कहा था इनिशियली कि अगर हम 0 को एडजॉइन करें किसी सेमी ग्रुप में,